So how do we know where an earthquake actually occurred? Well, to do that, we need at least 3 recording stations with seismographs that actually can detect the seismic waves traveling through the earth. Now, there are 3 main kinds of seismic waves. There are the surface waves that travel along the surface. They're the ones that can do a lot of damage to buildings because in extreme cases, you can actually have the ground undulating up and down. But to figure out where the earthquake occurred, we actually need the other 2 types of seismic waves. They're lumped together and they're called body waves because they travel through the interior or body of the earth. And body waves can be divided into P waves for primary and S waves for secondary. The primary waves are called primary because they travel fastest and they arrive at a recording station first. The secondary waves are the slowpokes. They travel slower and they get there later. Think the turtle and the hare. The hare, the fast ones, are the P waves. The turtle, the slow ones, are the S waves. Now, they both start off at the same time. So the farther away you are from the actual location of the quake, the larger the gap between when the first P wave arrives and the first S wave arrives. If you're relatively close to where that quake started, the lag time between when you detect the first P wave and the first S wave is going to be very short. But if you're very far away from where that quake originated, there's going to be a very long gap in time between the P wave and the S wave arriving. So that tells you how far away you are. But in what direction did it occur? That's why you need the 3 stations. So let's assuming that we have one seismograph and we know that the quake occurred somewhere 500 miles away. So what I do is I draw a circle on a map that's 500 miles away from that recording station. And that quake occurred somewhere along that pink circle. But I can't tell you exactly where. In order to figure that out, I need another station. So let's say that I have another station and I know that the quake originated 250 miles away. So I draw a circle 250 miles in every direction away from that second recording station. I've done that in brown. Now hopefully you can see that the pink circle and the brown circle intersect in 2 places. So the quake originated in one of those 2 places. In order to narrow it down even further, I need a 3rd recording station. And so let's imagine that I have a 3rd recording station, and that recording station is 750 miles away from the quake. So again, I draw another circle, 750 miles in every direction away from that 3rd station, and that 3rd circle is green. And you can see that the 3 circles only intersect in one unique location, and that's where the quake occurred.